Hi everyone, we are excited to present our project titled Microcontroller Based Washing Machine Simulation using PICSIMLAB. This project was carried out by me, K. Bharati, along with my teammates Kundanashri and Venkateshan from SSN College of Engineering. This is the structure of our presentation. We will begin with an introduction to the project, explain about microcontrollers, PICSIMLAB and embedded systems. Then we will cover the software tools, go through embedded C concepts, the actual embedded program and wrap with the advantages, disadvantages and a demo. Washing machines are essential appliances designed to reduce human efforts and save time in the past. In the past, manual scrubbing was required, but now, with the development of fully automatic machines, the entire process is automated. In our project, we simulate a basic washing machine that runs a spin timer using the PIC16F877A microcontrollers. Microcontrollers and microprocessors are widely used in electronic devices, phones, control systems, laptops, etc. They perform repetitive operations and are low cost, reliable, and compact. What is a microcontroller? A microcontroller is a small programmable integrated circuit used to control a specific task. It has limitations in memory, input output pins, and peripherals, but it's very efficient for embedded application like ours. Microcontrollers versus microprocessors. Microcontrollers are optimized for control based applications like a washing machine, whereas microprocessors are used in general purpose systems like laptops. Microcontrollers have integrated memory and input output ports, making them more efficient for embedded tasks. This is PICSIMLAB architecture. We used PICSIMLAB to simulate the washing machine. It is a real-time emulator that mimics the behavior of microcontrollers and supports debugging with MPLAB X IDE. It gives us a visual interface like real hardware. It consists of GPIO, I2C, temperature sensor, analog to digital converter, CLCD, matrix keypad, digital keypads, and LEDs and buses. Why we are choosing a microcontrollers? We selected the PIC 16F877A based on application suitability, performance, availability of tools, special features like input output pins and timers. Embedded system introduction. An embedded system is a combination of hardware and software designed to perform a specific task. Our washing machine is an embedded system dedicated to controlling wash cycles. This is the examples of embedded system like game machines, electronic book, tablet, television, industry, airlines, space, broadcasting, medical, digital signage, amusement, printer, car, mobile phones, smartphones, camera. This is the block diagram of embedded system, and this is the type of embedded system: standalone, semi-automatic washing machines, real-time embedded systems, airbag system, base makers, networked embedded system like routers, mobile embedded systems like Google Car, and the hybrid embedded systems like robot. This is the requirements of embedded system: reliability, cost effectiveness, low power consumption, efficient usage of using processing power, efficient usage of memory. There are three types of real-time systems: hard real-time, critical task like airbags, firm real-time, slight deadline tolerance like washing machine cycles, soft real-time, less critical like multimedia streaming. Types of washing machines: semi-automatic, requires user input between stages; fully automatic, all stages are pre-programmed; front-loading or top-loading depending on where cloths are inserted. Principle of operations. The washing machine works in three main cycles: wash cycles, detergent and water, clean the cloths, rinse cycle, dirty water is drained, dry cycle, cloths are dried by spinning. Software tools: MPLAB X IDE. This is where we write, compile, and debug our embedded C code. PICSIMLAB is an emulator that allows us to test and run the project virtually. It shows how the switches and LCD would work on real hardware. What is C programming? C was developed in 1972 by Dennis Ritchie. It is a procedural programming language used for system level and embedded applications. It is fast, portable, and works close to hardware. Features of C languages: simple syntax, portability, modularity, efficiency, rich library. Here is a sample code that prints hello world using printf. What is embedded C? Embedded C is an extension of C used to program microcontrollers. It allows direct access to hardware, including registers and ports. It's used in automotive systems, IoT devices, and smart appliances. Features of embedded C: direct hardware access using memory mapped input output, efficient code for low memory and low power systems, interrupt handling and timing based operations, supports bit level operations, registers, and peripherals, compatible with various microcontroller architectures like 8051, AVR, PIC, ARM architecture. This is the Here is the basic program to blink an LED. In our simulation, we used an embedded program that controls LCD output, responds to button presses, simulates wash, rinse, dry based on user inputs. This is the advantages. Fully automatic washing machines save time, water, and effort. They adjust water levels and wash times automatically. Have a range of capacities for different needs. This is the disadvantages. However, there are some drawbacks: higher electricity consumption, costlier than semi-automatic options. To conclude, fully automatic washing machines are an efficient and smart choice, especially in urban homes. Our project simulates this logic using microcontrollers, making it suitable for embedded system learners. We refer to MTech and IEEE papers for simulation knowledge and embedded system design techniques. Now let's see the demo in PICSIMLAB.
Hello everyone, I am Venkatesan from SSN College of Engineering. I am going to explain about the washing machine program and the working. So first we see the user interface. Usually the user will switch on the washing machine. He will press the power on button. Then the user will select the options, the mode of options. Then he will set the water level. Once he set the water level, will press the start button to start washing. Once the washing machine is started, the duration of washing will be displayed. Once the duration ends, it will stop washing. So this is the main program. So we have created a project named as washing machine. Under this, we have created header files, source files, and other important files. So under header files, we have included the peripherals. So in CLCD, we have included the macros, which is essential for that peripherals, and digital keypad. We defined the macros necessary for the peripherals, and here is the macros for the timers, and here is the macros for washing machine function. And we have clubbed all the four peripherals in one header files named as main.h. And we are using the user defined header files in main function. That's why we included the directives as hash include main.h. So once the program is executed, the the program will execute at the main function. It will start at the main function, and it will start executing the lines after that. So it will first run the command of init config. So the init config line is executed where it initializes the LCD, it initializes the digital keypad, it initializes the timer, then initializes also the interrupt also. So once initialization was done, the LCD will print press key 5 in line 1 starting from first column, then power on in second line starting from fifth column, then washing machine at third line starting from first column. So once when we on the washing machine, it will print these three lines in LCD that we can see here. So basically LCD contains 16 cross 4 matrices where we can write 16 characters in one line. So we have written press key 5 2 in first line starting from first column, power on in second line starting from fifth column, washing machine in third line starting from first column, and the last line is kept empty. After displaying this, we have to press key 5. In order to configure this, we need to configure the digital keypad RB4 as switch 5. When switch 5 is pressed, the LCD will print power on washing machine. So let's see we can code this. So once this line is executed and switch 5 is pressed, the LCD will clear the older commands and it will execute the next line power on screen. So that function is here. So the power on screen will be executing now. So first it will print the LCD first line as block of 16 characters, and second line starting from third column it will print powering on, and starting from first column in third line it will print washing machine, and the fourth line is filled with blocks up to 16th row. Okay, once this was completed, it will clear the screen, then it will move to the selecting the modes. So now we have to configure the washing machine program. So in order to configure the program for the switching for the various modes, we need to configure the switch 4. So if you press switch 4 once, it will move to various options. If you long press it, it will select that options. For example, see here. So if you press switch 4 once, it will clear the previously shown LCD commands, and it will print the washing machine program in line 1 starting from 0th column. So in line 2 it will show the modes which is in array of washing program. So it will shown one by one in array like daily, heavy, dedicates, like this. So if you press switch 4, it will toggling to next modes. When we press the switch 4 for a long time, it will select and moves our LCD to water level. So once it is done, when long press switch is done, it will move to the water levels. So here it will again make the LCD to set the water levels. So first it will print water level in line 1 starting from 0th column, and line 2 it will print the array of water levels like auto, low, medium, high, and max, like this. So it will show the options like this. Similar way we have to configure switch 4 for selecting the keys for the switching the modes, and if we long press the switch 4, it will select the water levels and moves to the next window. So in this window we are actually starting and stop the washing machine. So in order to do this, you have to configure switch 5 as start, switch 6 as stop. So if you press switch 5, it will start the program. Okay, so in main function, if switch 5 is pressed once, it will start the washing machine, turning on the timer and the fan on. So for each kind of mode, there is respective time seconds, durations of washing the clothes. So for each mode, it will wash the clothes accordingly. So once the program was completed, it will shows us program completed, remove the clothes in LCD. So like this. So once the user click the start button, the washing machine will start the washing. It will rotate the motor. So during this time, the user unfortunately opened the door. It acts as an interrupt to the microcontroller. It will interrupt the microcontroller by stopping the motor to rotate. So the microcontroller will instruct the user that door is open, please close it. So it will also indicate with the buzzer. So if the user will close the door, the program will start continuing, and the washing machine will start rotating and stops until the end of the time.
So, hi, Kundana here again. So, we just saw all our project files now. These are all our project files. So, let's get to demo. This is the MPLAB IDE application where you save it, then you say build main project. This will build a project, and build was successful. Build was successful. Now you open PICSIMLAB and make sure you choose the right microcontroller, and you load the hex file which has been generated by your build. So say load hex and choose this hex, say open, and here we see our the display showing press key 5 to power on the washing machine. So you must note that this is button 1, 2, 3, 4, 5, 6. These are the 6 buttons that we'll be using. So this is our key 5. So let's just press it. There you see powering on washing machine. So this is a washing program. We click the key 4 to keep switching between the uh, items. So, and long press to choose the item. So we have daily, heavy, dedicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store, and back to daily. So let's long press and choose daily. Now we have the next item, which is water level, where we have auto, low, medium, high, max, and back to auto. Okay, let's just go with low. So this is our switch 5 is the start button and switch 6 is the stop button. So let's just start our washing machine. So for our daily program, we have for simulation purposes, we just give 32 seconds. So we have switch 5, switch 6 for pause, and switch 5 to start it again. So let's just test it out. Switch 6 pauses the fan and the cooler, and switch 5 runs it again. This fan indicates that a motor is running and the washing is happening. So uh, this is our opening of the door button. Let's just click and test it while it's running. So we see the buzzer is going on because we have opened the door. So we can pause it again. So okay, after our program gets over, we also get a beep and we are back to the washing program. There's this reset button which just goes back to the starting screen. So this is our project on simulating washing machine using MPLAB IDE and PICSIMLAB using the microcontroller PIC16F8778. And I also want to take this moment to thank Amatext for this great opportunity for creating this project. We have learned a lot of things, new things on this project, and I'm glad that Amatext continues to give our students these opportunities. So with that, Skundana signing off. Thank you.